In this video, we will look at periodicity and the trends in the periodic table. But before we get into that, I would like us to go through some definitions that you need to know for exam purposes, and that will be very useful as we look at periodic trends and periodicity. Let's start with atomic radius. It is the measure of the size of an atom. Ionization energy, we have the first ionization energy, second, third, and fourth, and so on. The first ionization energy is the energy needed to remove one electron from an atom in the gas phase. So a second ionization energy will be the energy that we need to remove 2 electrons from an atom in the gas phase, and the third ionization energy will be the energy that we need to remove 3 electrons. So I think you get it now. So that's how you define ionization energy, but in the exam you just need to define the first ionization energy. You don't need to define second, third, fourth, etc. Electron affinity is the change in energy that takes place when a neutral atom in the gaseous state accepts an electron to form an anion. Remember what an anion is? An anion is a negative charge. It can also be thought of as how much an element wants electrons. So if you don't remember this long definition, you can just say it's how much an element wants electrons. So electron affinity measures how much an element wants electrons. You can just say that. Electronegativity is the tendency of atoms to attract electrons. So remember, you need to know all of these definitions for exam purposes. Let's look at some of the trends on the periodic table. So the figure 5.4 below shows the trends in the groups on the periodic table. Remember, we said that groups are vertical in the periodic table. The atomic radius increases down the group. It increases down the group. Ionization energy increases as you go up the group. Electronegativity, melting, and boiling point, they also increase as you go up the group. And density, like atomic radius, it decreases as you go up the group. So it increases as you go down the group, and it decreases as you go up the group. Then let's look at trends in groups of the periodic table and periods in the periodic table. My bad. Periods, we did look at groups on the previous slide. Okay, so electronegativity increases as you move from left to right of the periodic table. Ionization energy also increases as you move from left to right, and atomic radius decreases as you move from left to right. So atomic radius increases as you go from right to left of the periodic table. You also need to know these trends of the periodic table. Periodicity. What is periodicity? It is the gradual change in chemical and physical properties of elements when moving from left to right in a period. So we did say that as you move from left to right in a periodic table, you get changes in chemical and physical properties of the elements. Certain patterns in the changes of the physical and chemical properties can be observed. This relates to the atomic structure of the elements. We'll look at elements in period 2 and 3 and investigate the periodicity of certain properties. So we'll investigate density, melting and boiling points, atomic radius, ionization energy, electron affinity, and electronegativity. Let us now look at density. Remember, I said that density is equal to mass divided by volume. So the density, or the packing of the atoms of an element, is determined by the bonds between the atoms of the element. So the packing of the atoms, whether the atoms of the element make up a solid or a gas, affect density. In period 2, the density of the solids lithium, beryllium, boron, and carbon increases in this sequence. So the density of lithium is less than the density of beryllium, which is less than the density of boron, which is less than the density of carbon. So carbon has the largest density compared to all three solids, lithium, beryllium, and boron. But the gases in period 2, nitrogen, oxygen, fluorine, and neon, their density decreases in this sequence. So nitrogen has the largest density and neon has the smallest density. So in period 2, the density of the metals or solids increases and that of non-metals decreases across the period from left to right. So as you can see in this diagram below, we have the solid line represents period 2 elements and the dotted lines represent period 3 elements. So period 3 also follows a similar trend to period 2, because also for period 2, for period 3, the density of the metals increases as you move from left to right, and that of non-metals decreases as you move from left to right. Let's move on to melting and boiling points. The melting and boiling points of an element depend on how much energy is needed to overcome the forces of attraction between the particles. So you can imagine that if your forces of attraction are very, very strong, then you are going to need higher melting and boiling points to overcome those forces of attraction. That is a well-known fact. So solids have higher melting points than gases, and therefore there's an increase from lithium to carbon. Nitrogen, oxygen, fluorine, and neon have melting points that are less than 0 degrees Celsius, with a decrease in melting points from nitrogen to neon. So remember, nitrogen, oxygen, fluorine, and neon, as we saw on the previous slide when we look at density, they are gases. So the forces of attraction between gas particles, we did this when we did the states of matter. So we did this and we said that gas particles have weak forces of attraction between them. So it makes sense that the gases have melting points that are less than 0 degrees Celsius. The same trend is evident with regard to the period 3 elements. So as you can see on the diagram below, you have hydrogen and helium. They have a melting point that is below 0. And then from lithium to carbon, it increases. Then your neon, your nitrogen, oxygen, fluorine, and neon, again, they have a melting point that is less than 0, and neon has the highest melting point compared to, has the lowest melting point, has the lowest melting point compared to all three. And period 3 also follows the same trend. The higher peak values of carbon and silicon, as you can see on the diagram below, carbon and silicon both have highest peaks compared to the other elements in the same period. So this shows that strong forces exist between the atoms of these elements. So strong forces exist between the atoms of carbon and silicon. Carbon is we usually see carbon in diamond and graphite. So it does make sense that there are strong forces between carbon atoms, because a diamond is very, very strong, and graphite as well. Within a particular group, the melting points decrease down the group. So now we're talking about groups. Melting point will decrease down a group. So if you look at lithium and sodium, then you look at beryllium and magnesium. So lithium has a higher melting point than sodium, and beryllium has a higher melting point than magnesium. And beryllium is above magnesium in the periodic table. So you can see that as you go down the group, your melting point decreases. With regard to the halogens, there is an increase in melting point down the group. So the halogens, they have an exception. So they are an exception in the decreasing melting point down the group. When you look at them, there is an increase in melting point as you go down the group. So the melting point of fluorine is less than the melting point of chlorine, which is less than the melting point of bromine. The pattern for boiling points corresponds to that of melting points. So melting points and boiling points have the same pattern in the periodic table. Let's move on to the atomic radius. An atomic radius is the distance between the atomic nucleus and the outermost orbital with electrons. It is also half of the distance between two adjacent atoms. So as you can see on the diagram below, we have two atoms, and atomic radius could be the distance between the two adjacent atoms. It's the half of the distance between these two adjacent atoms. And so what is the periodic trend with regard to the atomic radius? The atomic radius increases as you go down a group. So as you move from top to bottom of the group, your atomic radius increases. Why is that? It is because as you move down in the group, a new energy level is added each time. So you add a new energy level as you move from group 1 to 2, from group 2 to 3, from group 3 to 4, etc. And so if you add a new energy level, the valence electrons will be farther away from the nucleus, and they will be increasingly shielded from the nucleus by the growing number of levels with inner electrons. So you can think of this as a group of people who have created a circle for people to come and dance at the center of the circle. As this circle of people grows, the people at the back will not be able to see clearly the person who is dancing at the center of the circle. Their view will be blocked, or they are going to be shielded by the people at the front. So you can think of the person who is dancing at the center of the circle as the nucleus, and then you can think of the people at the back of the circle, or the people who are making the circle, as energy levels. So you can see now why the valence electrons are shielded, because the valence electrons are the outermost electrons. So they are the electrons at the back of the circle. They are the people at the back of the circle. And so if the valence electrons are shielded, the force of attraction between the nucleus and the valence electrons, because they are very, very further away from each other, will be weak. And so the atomic radius will increase. So if the force of attraction between the nucleus and the valence electrons is weak, then it means that the atomic radius will increase. And if the force of attraction between the nucleus and the valence electrons is strong, then the atomic radius will decrease. And then let us see the trend in the periods of the periodic table. So the atomic radius will decrease from left to right in the period. So as you move from left to right in the periodic table, your atomic radius decreases. Why is that? It is because the energy levels remain constant. So you don't add any new energy levels as you move from left to right in the periodic table. And so your inner electrons of the atoms, they remain constant as well. One valence electron is added to the same outer energy level. So as you do not add, you are not adding a new outer energy level, but you are adding one valence electron. So the number of protons in the nucleus will increase, and if the number of protons in the nucleus increase, the nuclear charge also increases. So if the nuclear charge increases, it means that the force of attraction becomes strong, and so the atomic radius will decrease. That is it for this video. On the next video, we will continue looking at the trends in the periodic table.